We have dealt with the basic understanding about how energy is created in the cell. And now we get into where did mitochondria come from? Very interesting part. Mitochondria, and this is the part that I'm baffled with. When I heard, when I learned about it, I was baffled. I mean, I've learned it a few years ago, but I'm totally baffled about this now that I understand it a lot more. All mitochondria in the world, and I'm going to stop here a little bit to take a deep breath, for everybody to take a little deep breath. All mitochondria in the world, that means all energy units that produce any amount of energy in human cells, come only from the female genes. They come only from the females. Males do not have any contribution. Males do not have any contribution to any energy. We call that Devi. Why we call Devi and Shakti? Why we call Shakti? Shakti and that energy comes only from the mother. Father has hardly any contribution. Hardly any. I'll explain to you why. The science behind it, and I'll explain the science so you'll know. And so, how many mitochondria are there in a given cell? Okay, in a given cell, there can be multiple mitochondria because you need more energy stations, and mitochondria can be more or less, can be more number or less. The average number, see, the more active the cell, the more number you need. Makes sense, right? The more active the cell, the more energy is required, and you require more energy. For example, I need a heater. I have a space heater here. I have, on the heater put on the, because I need heating of number of areas, and so I need more mitochondria. I need more productivity cells. Productivity, not cells, but productive mitochondria. Now, and that's why I start saying mitochondria, MITO, and now I'm going to say MIGST, mitochondria. It's a mite. Is really energy. So I'm going to go to the step where how many mitochondria. Now, out of all the cells, can you imagine one cell that works and requires a lot of energy? It's obvious. It's the heart. Heart works continuously, completely, all the time. And so heart, for example, has average about 5,000 mitochondria per cell. In every cell, about 5,000 mitochondria. Huge number. And it's located in certain areas. It's not all over the heart. Also every cell's average, but it's average about 5,000 mitochondria. And the liver, for example, about 2,000 mitochondria. About 2,000 average. Now, when you go to the next one, I mean, kidney has around that 1,000 to average about 1,200 to something like that. And these are the active organs. What about the brain? Fascinating part. Brain is also quite active, and brain has to continuously mass it. There's a cell. There's a tail called the axon. The axon that connects, axon is like a tail, and the tail connects to the next station. They're like a cellular station, like you have cellular station like you have in our cellular phone. There are a number of stations. There is a relay from one station to the other station to the other station. That's how the network is there. It's a cellular network, we call it, right? Network is lost. And that's the network. See, we have it in the brain and nervous system. So that thread that is called axon and dendrites, these are the axon. Now, fascinating part is that the message system, the connection between one and the two, there's a little jumping of the electric message. And like somebody carries the electric message, I give the message to you, and then you go to somebody else. That's how the message system works. You give it's a courier, like the courier. We talk about hand courier. Same way the courier messaging system works in the brain. And that message system takes quite a bit of energy. message system takes quite a bit of energy. And that energy, therefore, there's going to be concentrated in those areas. And in fact, tomorrow we'll talk more about it, but these mitochondria actually move. They are not stable. They move. There's movement. And the movement happens, believe it or not, it's an amazing number. And when I learned about that, my mind was blown. It's almost 86 millimeter per day. Imagine how big is that movement for, and it's within the cell, like it's a small, tiny little piece, within the cell. And that's the amount of movement. And there are some proteins that move it and all, don't worry about that. But the movement. So movement happens in the nervous system, in the brain. And that's where there is an important aspect that they get concentrated in one area a lot more. And here's the important part. Why they concentrate? Because that's functioning, the message system is working, and they get concentrated because it's functioning. It requires energy. It conducts the energy. Somebody has the thing, please turn off the, and then what happens is you have a situation where the movement that's happening carries the amount of message, and movement carries the energy. So if there's more movement, it requires more energy. And then more energy is used also because of the movement. It's both ways. And the body sees to it that more mitochondria are created. And this is called biogenesis. It means creation of new mitochondria. Biogenesis. So biogenesis is an important aspect. Now, it's obvious now that what we're dealing with here is when you have movement, when the active cells and activity is therefore creates more mitochondria, more energy. Does it start making sense why we talk about move and get more energy? It start making sense because of this whole aspect that we're talking about. And I was blown away at the numbers in central nervous system. The mitochondria can amount to 2 million sometimes. Now, that was a huge number for me to even digest it, but I could do more research about it to find out where it is and how it works. I'm trying to locate the placements and everything in various figures. And many of these numbers are like in 2023, 24, 25 papers. Okay, these are very recent stuff. But anyway, so now we have the numbers. Now, interesting part about this is we talked about all these in the various organs. Skin has less. Skin is much less because it's like 40, 50, something like that. Not too many percent because there's not that much active. So go to one more thing is the ovum. Ova that females have. It's called ovocyte. They produce ovocyte in the ovaries, okay, and from which the ovum gets menstruation, and then ovum gets ovulation happens. And the ovulation the ovum gets, and then the sperm gets to the ovum, and that's how we have a baby formed. You know all that. Ovocyte has 100,000 to 600,000 mitochondria. 100,000 to 600,000. Just imagine. Therefore, the nature gives us a package, an energy package, huge energy package already. This is the mother. I'm going to give you the mother who is going to give you the energy. That is the true message through the numbers. How many does the sperm have? You'll be surprised. Between 50 to 70. The poor guy just goes like that. Only motility, It's the only motility part. There's no other work that he has to do. He does the little motility and then impregnates the ovum. Done. My work is done, That's how this is. Can you imagine this? So now, this is a man's world. Oh, why the heck? Just learn the biology. It's not a man's world. It's a woman's world. It is woman's world. Biologically, it is Devi. How many times can we repeat this? No, this is exactly what it is. People need to know this. Now, the difference is this. So all analysis are done. These are all papers. These are all absolute numbers. Okay, you can check it out. But nowadays, people want to find exceptions. So no. But we found a couple of cases, couple of families where they found we found the mitochondria from a man. Within the now they started explaining why it happens. Sometimes that happens because, see, most of the mitochondria, there are two types of DNAs, okay? Most of the DNAs are located in the nucleus. And the nuclear DNA, therefore, is mainly involved with the genes, like genetics, like what the type of person is formed, etc., etc. All genetics, all the genetics that are there, that is there. And the mitochondrial has to do with the energy part. Sometimes this little thing that gets into the nucleus, and the nucleus divides and gives to the next cell like that. So sometimes these genes, these mitochondrial element, mtDNA call, that gets into the nucleus sometimes for some reason or the other, because the nuclear membrane may not be intact, and that can happen sometimes, and that's how they explain it. But it is all mother. Now I'm going to get some numbers, and then I will have 10 minutes. We'll do some practices, but I'm going to go through some numbers here, and these numbers are very fascinating. How much of ATP are produced per day? ATP is the unit. Believe it or not, ATP, the amount of ATP, supposing we were to weigh the ATP, it produces equivalent to your body weight. If you have 60 kilogram of ATP is produced every day at rest. Imagine how much, and it's all inside. ATP is all inside the cells. It's not like that billions of cells. Okay, so it all adds up to about that much of ATP. And at maximum exercise, supposing you exercise, at every exercise, so for example, 0.5 to 1 kilogram of ATP is produced per minute of exercise. So imagine how much of energy you can generate per minute. 20 kilogram force of 20 minutes of exercise. So we do good amount of exercise, ATP is produced, and mitochondria is working. So yes, mitochondria is working, the energy is there, but you have to recover too. That's where the oxygen comes in and oxygen debt comes in. Now, every cell, for example, the average cell uses, now, cell also uses the ATP. It produces ATP, but the cells use ATP. And the numbers are mind-boggling, to me at least. Every cell uses 10 billion ATPs per day. 10 billion ATPs per day. And an adult is 3 multiplied by 10 raised to 25 ATPs per day. And I talked about ATP to ADP recycling. That happens about 1,000 times a day in every cell. ATP to ADP, ADP to ATP, 1,000 times a day. This is can you imagine how much activity continues to happen in our body? Unbelievable. So we are all, whether we are sitting at rest or whatever, it's now. One more thing I will tell you, and before we start moving on, and that is electricity. Energy is also measured in electricity, but they also say how much of wattage is created. Average at any given time, there are 250 grams of ATP in a cell, and it creates equivalent to about 4.25 watts. Every cell creates about 4, and like a AA battery. A AA battery, like every cell is a battery, it produces 4.25 watts. And a healthy person produces 1,200 watts per day. At 1,200 watts is like a refrigerator. Refrigerator is typically around 1,200 watts. That much power we have creates every day. And the brain uses about 10% of ATP. So that what happens is that's a lot actually, compared to other organs. It uses a lot, and therefore, when the energy is down, brain is the one which starts suffering more. That's why we start the degenerative disease. If our mitochondrial function is not good, we will have neurological problems. Address the neurological problems by fixing the mitochondrial machine. That's very crucial. So I will end the numbers game here, and we'll do some practices.